So it is a technical session. We'll be getting into the technical bits and bytes, but I'll try at every point to really not just look at the technical aspect of things, but also look at the benefit that it has from a business standpoint. So with that, welcome, and let's get started. I guess the only other housekeeping thing that I'll mention is Brandy, my partner in crime here, will be monitoring the chat. So if you've got any questions, I won't be able to see it, but Brandy, just put it in the chat window, and I can answer that. Brandy will flag me, and I'll answer those for you. All right. So indeed, this is the biggest hardware update in NetApp history. As you'll see, not only we've pretty much refreshed the entire product line. So our entire hybrid solutions, we've refreshed the entire all-flash offering. We've refreshed the disk themselves, the disk shelves, the shelf enclosures. We've done some technology updates on the disks themselves. So that's it's on too much, but there's a few little things there that are quite interesting that we've done, that the engineering team has done. We've refreshed the interconnect capabilities, so whether that's fiber channel over 32 gig or Ethernet over 40 gig. So from top to bottom, the entire product set has been refreshed, and really this is what I want to dive into a little bit here. There's sort of three main themes when it comes to the overarching concept for this update. Really flash everywhere, and what I mean by that is not just within our all-flash product line. Obviously, we'll talk about what we're doing there, but flash into the going down into the entry-level systems, the hybrid systems. So just this overarching concept from an engineering standpoint to leverage flash pretty much in all potential locations. Of course, leveraging the new technology gives us more speed, more performance. You'll see the updates on the comparison relative to the existing controller platforms, and you'll be very impressed with that. And then density and connectivity. Obviously, I talked a little bit about the 32 gig and 40 gig from a connectivity standpoint. We'll double click down on that, as well as some things that we're doing from a density, not just on the SSD. Obviously, we're adopting trends within the SSD space, so going from the 3.8 to the 15 terabyte SSD drives, and you'll see the leaps and bounds on the SSDs are quite impressive. So going from 15, the next generation I think is 32 terabyte SSDs. So the software itself is built to take advantage of that. So anyway, those are the overarching flash everywhere, faster, 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 density and connectivity. Let's get going. So right off the top here, we'll talk about the hybrid controllers. So these are the FAS product line. Right now, this is our current offering. So on the entry level, we've had three offerings: the 2520, 2554, and 52. At the mid-range, we've had the 8020 and the 8040, and then at the high end, the 8060 and the 8080. What we've done is we've refreshed that product line and also simplified it. So we've gone down to three products. So we've consolidated that space, that entry-level space, into the FAS 2600. That mid-range will be the FAS 8200, and at the very high end, the FAS 9000. The FAS 9000 is actually a very revolutionary design from a NetApp perspective. We'll talk a little bit about that. We've gone to a chassis-based system, and so there's some interesting benefits around that. So that is the simplification. So from the 2, 4, 6, roughly about 9 platforms that we had before, down to 3. So let's start off with the FAS 2600. That's our entry-level platform. As I mentioned, one of the innovations that we've done is to put NVMe memory, NVMe flash, into all of the platforms, except all of the hybrid platforms, even down into the entry level. So the FAS 2600, our entry-level platform, has 1 terabyte of NVMe read cache. In addition, we've also increased the CPU core significantly. So we've gone from 4 cores in our previous generation to 12 cores. And we've got onboard 10 gig and 16 gig fiber channel connectivity. So a tremendous amount of power in the very small form factor at a entry-level price. This is a 2-rack unit system. The one thing that we've done actually from a software standpoint, I don't really mention it on the slide here, but in the past we've always said if you're a NetApp customer and you're using flash cache versus flash, it's often been versus flash pools. It's a one versus the other. We've done a number of modifications to ONTAP to allow for both flash cache, i.e. this 1 terabyte NVMe card, to work in conjunction with the flash pools. So you can still have flash pools, which is our technology which combines SSD drives with either SAS or SATA drive or NL-SAS drives, and to create this hybrid, often called a hybrid aggregate. So we can combine flash pools with flash cache, and so it's no longer one or the other. And so that 1 terabyte, even if you're using flash pools, is still very valid and actually adds a tremendous amount of performance as a secondary cache. We will be offering two configurations of the FAS 2600. There is a SAS hybrid configuration, so that's based on combining within the 2U chassis or 2U device. If you pull back the front panel or the front bezel, there'll be 24 drives. Those will be sold in a combination of SSD drives and SAS drives. And then the SATA or the NL-SAS version will have 12 drives. And that will be, again, a combination of SSD and NL-SAS capable drives. The difference between the two is because we're using the 3.5-inch large form factor with the NL or the SAS drives, or the SATA drives. So the NL-SAS drives are using the 3.5, the SAS drives are using the 2.5. So obviously we can squeeze a lot more drives into that form factor. I don't know, Brandy, any questions on the line around the 2600?
Nope, not yet.
No? All right. As I mentioned, we've really cranked up the CPU capabilities. So what we've done here is, from a performance improvement, this box is absolutely killer. I think we're going to be quite successful in selling a number of these. The performance boost over the current generation of 2500s is about 200%. So the equivalent of, if you wanted to, consolidating down 4 of the existing 2554s into a single 2600. So a huge performance boost over the current generation platform. All right. So that is the 2600. I mean, incredible amount of performance for an entry-level platform. At the mid-range, we've got our 8200 series platform. So similar to the 8000, this platform is based on, it doesn't have any internal drives, unlike the 2600. So it would connect out into external shelves, and we'll talk a little bit about that. Here's the rear view of the 8200 series. So you see the 2 controllers, A and B. you'll see that it's equipped with 4 SAS3 12 gigabit per second ports, so that would allow us to connect to our new 12 gigabit per second SAS shelves. It also has the UTA ports. So these UTA ports, if you haven't used them before, can be configured in pairs as either 10 gig Ethernet or 16 gig fiber channel. So you see the little ports there, the 4 that have a split between the green and the orange with a little plus sign. Those 4 ports, 4 per controller, can be configured to support either 10 gig Ethernet or 16 gig fiber channel. And so you could do 2 ports, 16 gig fiber channel, and 2 ports, 10 gig Ethernet. Again, providing you that unified storage platform. We've also included 10 gig base T on this platform as well too. Again, for some customers within their infrastructure, they like, if they want to continue to leverage that base T infrastructure, they can do that. We have 2 expansion slots which can be populated with 40 gig or 32 gig fiber channels. So this is where we start to talk about the connectivity options for next generation data centers. So as customers are looking to go from 10 gig to 40 gig, from 16 gig fiber channel to 32 gig fiber channel, this platform absolutely fits within that that roadmap. So you can start off with this, in its base configuration, and then if you want to add 40 gig cards or 32 gig fiber channel cards, you can absolutely do that in this platform. This system comes with 2 terabytes of NVMe read cache. We've increased the number of cores from 12 to 32 from the existing generation of 8040. And obviously, as I mentioned there, the ability to do 40 gig and 32 gig fiber channel. From a performance comparison, I guess before I jump to the performance, it does connect into the 2 new shelves that we have. I'll touch on those a little bit later on in the presentation. So these are the DS 224C and the 212C. We'll talk a little bit more about those, but those provide the connectivity for either SAS and SSD or SATA. The platform is approximately 50% faster than the current generation of 8040. So again, giving you a very healthy performance boost over the current hardware platform. So that is the 8200. Moving on. So this is the Big Daddy, the FAS 9000. It's a new design from a NetApp perspective, where in the past we've had either the similar design to the 2600, where you've had the controllers in the back and disk capability, the ability to have disks in the front, or similar to the 8200, where you've had the controller and separated the controller with I/O cards in it. What we've done here with the 9000 is we've got the controllers in the middle and the I/O cards on the outside. And this is really to provide, both from a future-proofing standpoint, as well as simplifying the cabling and upgrade when it comes to the controllers themselves. Actually, what I've got here under this blanket is the FAS 9000. So I'll do my reveal here. So this is I hope you guys like that. I've been practicing the flick. So this is the FAS 9000. So what you'll see on the back here is the controller modules. I can probably even zoom in a little bit on that. Now, let's see. Go a little bit over to the left. So we've got the two controller modules there, and then we've got slots. So from a RAS perspective, upgrade perspective, you can see here how easy it is for us to just be able to pull out the CPU module, right? Very basic connectivity on the back of the CPU module. You've got a serial port and one Ethernet management port, and a mini USB as far as serial connectivity into it, but that's it. So where in the past, if you've had to do any sort of controller upgrade, you have to be aware of the cabling and how it's all connected, etc. This makes that whole process, really simplifies that down. The cabling stays, the connectivity stays the same. You're simply just upgrading the controller module. So you pull out the controller module, you put in the new controller module, and away you go. Can I go back to my YouTube? Oh. So that's the FAS 9000, and we'll dive into it a little bit more here. From a CPU standpoint,
Tony, they'd like to see you lift it.
It is 200 pounds. So yes.
210.
210. You will not be seeing me lift it. We had a heck of a time even getting it on the table. So Brandy has patented the Lazy Susan that's underneath it. That's her design. So patent pending. No, so from a technical perspective, we've increased the number of CPU cores. This platform has 72 cores. It's configured with 2 terabytes of NVMe read cache, upgradable to 16. From a performance standpoint, this platform is approximately 2 times the performance of our current top-of-the-line 8080. So this is a very powerful system, really looking at, for use cases where customers are looking to do some significant consolidation. Not only that, but from an I/O perspective, the base unit comes with 2 quad SAS3 ports for connectivity into the disk shelves, and 2 40 gig ports. And obviously, we have the ability afterwards to configure the system to suit your needs. So whether the remaining 16 I/O slots can be configured with 32 gig fiber channel ports, additional 40 gig ports, 10 gig ports. I mentioned there's the ability to expand the amount of NVMe read cache. We've got a 4 terabyte NVMe read cache card. We can add more SAS cards. So really the ability to tweak and tune that environment to suit your needs. The nice thing by separating out the controllers and the I/O, as I mentioned, not only does it simplify the upgrade process when you're doing controller upgrades, but it also allows you to independently change the I/O from the controller. So if you have an environment where initially you may be using 10 gig initially, and then you decide to move up to 40 gig in the future, that can be done quite easily just by adding the specific card into the I/O slots on the right and left there. I mentioned the consolidation factor. This system, the FAS 9000, will support 60 shelves or 1,440 drives. If we look at that's roughly about 10 petabytes worth of storage behind this controller. So the number that you'll see to the right of those disk shelf numbers are the number of disks or the number of disk shelves that we can connect into this system. So,
Tony, we have a question. Keith is answering it. If we want to do a horizontal scale out, do we still need infinity band switch, or can we use the 40 GBE for clustering?
Yeah, so for scale out, obviously, this is the 2-node environment. There is, I'll talk a little bit about the 40 gig cluster interconnect. So we've upgraded our cluster interconnect, which is really the spine of a NetApp, of an ONTAP cluster. So we've upgraded that from 40 gigs, or from 10 gigs to 40 gigs. And so if you had 2 of these systems, you would use that cluster interconnect, that 40 gig, 2 ports of the 40 gig here going up to the cluster interconnect. Your other FAS unit, your other FAS 9000 would use some additional ports on that 40 gig. Hopefully that's what Keith said.
Something like that.
Something like that? All right. So moving on, so that's, again, really a simplification of the hybrid product line, simplifying it down to the 3 products, the 2600, the 8200, and the FAS 9000. A tremendous amount of, performance improvement over the existing product line, the flash everywhere. So that's, in a nutshell, the hybrid upgrade, right? The hybrid update. Moving on to the flash, the all flash product line. So these systems are all flash. We've made huge leaps and bounds when it comes to market positioning. About a year ago, probably, about a year and a half ago, we were quite far back as far as the marketplace. We were probably in 5th position. We are currently the number 2 flash vendor when it comes to storage. And at the the rate and the rate at which we're accelerating our growth on that platform, we anticipate giving EMC a run for their money at the number 1 spot. But we've made huge leaps in the market. Part of that has also been recognized by industry analysts. So this is the Gartner Magic Quadrant. So we are now in solidly in that leader space from a Gartner Magic Quadrant perspective. One of the things that I want to talk about that you'll notice here with the all-flash product line is that we've used the same, for the most part, there's one platform that's a little bit different, but we've used for the most part the same hardware components as our hybrid systems. But as these all-flash systems are all-flash, there are a number of things that we can do within the software to improve the performance. So for example, what I'm trying to illustrate here with the 8.2 to 8.3 to 9.0 versions of ONTAP is by eliminating the necessary steps which would otherwise be needed for spinning media, right? We can then improve the response time. So as you can see, the number of hops that we need to take within the code has significantly been reduced as we move from 8.2 to 9.0. What does that mean for you as a customer? It means that that same hardware platform, without changing anything, just changing the software, we're not changing any of the hardware components, we've gained a 64% performance improvement with software only. And we'll continue to do that as we move from 9 to 9.1 to 9.2 and beyond. Yeah.
Move your camera.
Pardon?
Move your camera.
Oh, move my camera. Oh, Brandy doesn't like to be on. She's shy. No, she's not. So that's so huge performance improvements just with the software capabilities. In addition, on the software side, one of the other things that we've done is NetApp has always been known for storage efficiency, right? Going way back to the VMware days and our deduplication technologies. What we've done is really amp that up with our all-flash systems. So there are specific capabilities from an inline perspective that are only available with our all-flash systems. So that includes inline deduplication, compression and compaction. So why can we do that? Well, we can do that because from a flash perspective, we're not paying the same penalty when it comes to implementing these technologies, where on the hybrid side, we have to be more aware of the fact that even with things like our flash pools, at some point we will hit that disk and we will have to deal with challenges associated with rotational media. So the reason why I highlight this is obviously the benefit from an all-flash perspective is the ability to logically have a lot more capacity in a much smaller footprint. So this is the current all-flash product line. So we've got nothing at the entry level, but we've got our AFF 8040 at the mid-range, and then the 8060 and the 8080 at the high end. We've introduced 3 platforms. At the entry level, the A200, at the mid-range, the A300, and at the high end, the A700. So if we look at the A200 and you were paying attention to the FAS 2600, this should seem very familiar to you. So this is based on the same hardware platform as far as the connectivity, whether 10 gig or 16 gig fiber channel ports on the back of the controller. The main difference, there's actually 2 differences. One obviously being the fact that this supports SSDs only. So if the front panel there, you won't see the 12 drive option. You'll only see the 24 drive configuration. And so this will support either the 960 gig 960 gig or the 3.8 terabyte SSD drives. We have the ability to not only have the drives within the internal controller, the 2 rack unit, but we also have the ability to expand that out with the expansion shelf, the DS224C. And this is at an entry level. So again, a tremendous amount of capabilities. I'll show you in a second here for an entry level all flash system. I like to call this the 130-130. So the single 2 rack unit with 3.8 terabyte SSDs will give you 130 terabyte at a 2-to-1 efficiency ratio, and that's fairly conservative, right? And 130,000 IOPS at 1 millisecond. And I base my IOPS testing on a 90-10 read-write ratio, because I know a lot of times people are throwing out numbers on these platforms and doing some strange things with benchmarks. 90-10 I think is a fairly reasonable amount, as far as the numbers that I've used there. So within, again, this is pretty phenomenal. Within a 2 rack unit, I'm getting 130 terabytes and 130,000 IOPS. 2 years ago, this was, you would need a frame-based system to deliver this type of capacity and performance. So if we look at that, actually, even if we look at our own hardware platform, and we look at that compared to our, the FAS 8020, we would need 3 of those systems to get the performance of a single A200. And then if we look at the capacity based on the 1.8 terabyte SAS drives, we would need 6 of those shells. So from a space consideration, this is huge. I mean, this is going from 21 rack units down to 2. Right? And so when you look at customers who are dealing with data center space constraints, whether they're in a colo and they're paying for data center space, even, I don't talk about the power and cooling, but as you can imagine, there is no rotational media on the A200. So from a power and cooling, it's got a tremendous amount of savings on that side as well too. So even if you're paying, you're not paying for space, but you're paying for power and on a kilowatt basis, there's a significant amount of business value that you can drive from getting one of these platforms. I know oftentimes the IT guys don't get that. It's not as though you get that money back necessarily. For some IT shops they do, but it's a great, you know, the data center space and power savings from a financial perspective can be very powerful when you're putting forward a business case to look at upgrading existing infrastructure. And that's at the entry level. So you know, you're talking entry level prices for that type of performance. Moving on to the mid-range. So this is the A300. I'm just doing a quick time check there. So the A300 is based on the same hardware platform as the 8200 series. So you'll see there the connectivity options are very similar. We have the 40 gig option there and the ability to connect expansion shelves. Again, these will only be SSD, will only support SSDs. With this A300 model, we do have support for the 15.3 terabyte SSD drives. So again, you can imagine some of the capabilities that we can, you know, configurations that we can do from a consolidation standpoint with those 15 terabyte drives. Roughly about 50% faster than the existing AFF 8040. So again, a big jump in performance, just based on the number of CPU cores that we've done, that we've put in this A300 platform. The one thing that I was going to mention here, I said there were two differences. Obviously, the all-flash being one of the differences. I forgot to mention what the other difference is that with these platforms, obviously because they're all-flash, we've removed the NVMe card because obviously these systems are all-flash. So that would be the other difference. And at the high end, we've got the A700. As you can probably guess, this is based on the same configuration as the FAS 9000. So it is a chassis-based system. We changed the bezel. We removed the NVMe card, and we connected up to SSD drives only. But the remainder, as far as the connectivity options, the number of I/O slots, etc., stays the same. Number of CPUs, etc., etc. Looking at some benchmarks here, the blue dotted line is the current AFF 8080 running ONTAP 9. The green line is the AFF A700 running ONTAP 9.1. This is running the SLOB test, so this is the Oracle benchmark. You'll see the highlighted where I've circled the I've got that little yellow circle. That is to highlight the knee and the bend from a performance standpoint. If you notice to the left-hand side, you'll see the latency there. We're talking about sub-millisecond latency. And obviously, from an all-flash perspective, those are the target numbers. Everything needs to be sub-1 millisecond. So, you know, if we look at a comparison, you can see how the A700 stays much lower from a latency standpoint, much further along that IOP benchmark. So we're closer to, you know, 500,000 IOPS there at, you know, sub 500 microseconds. So huge jumps there. As I mentioned, similar to the hybrid cousin, this is a 2x performance boost over the existing top-of-the-line platform. So that's the all-flash update. One of the things that I'm going to do here is give you a bit of a tech preview on the A700S. So it hasn't been released yet, but will be shortly. And so this platform has the same hardware specs from a CPU and main memory as the A700, but is really targeted at environments where you don't necessarily need all of the I/O capabilities and you're looking for more of a density play. So in the back of the, in the front, behind the bezel, this unit, this A700S, has internal drives in it. So we can house 24 of those SSD drives, whether that be the 960, the 3.8 terabyte, or the 15.3 terabyte SSDs. We will be offering two fixed options. So here's the back of the A700S. So we'll be offering a unified version. So this will include 32 gig fiber channel ports, as well as 40 gig Ethernet ports. And we'll be offering a 40 gig Ethernet option where we'll remove the 32 gig fiber channel ports and you'll just have 40 gig. You'll note there that each of the controller modules has 6 40 gig Ethernet ports. We'll use 2 of those for the cluster interconnect, and the rest are then used for data. We have the ability to expand this out beyond just the disks within the controller unit itself. So we can connect 3 expansion shelves to this A700S. From a performance standpoint, if we look at, if we had 2, the internal shelf plus 1 expansion shelf, given us 6 rack units. Ooh, that's a hard one. 6 rack units of the 15.3 terabytes. That would give us 1 petabyte of SSD storage and 500,000 IOPS. Because it is based on the same hardware platform as the A700, as far as the CPU cores and the memory configuration, the performance is similar to the A700. Any questions, or how are the questions coming on the? He's just handling them.
Keith is just taking them on so that we don't have to interrupt you.
All right.
If I see Keith not paying attention or like giving random answers that I think are wrong, I'll let you know.
All right. Thanks for keeping Keith honest. So a quick recap of the hardware product line. It is a simplification, so you can see there the pairing of the hybrid with the all-flash. So the 2600 and the A200 at the entry level, the 8200 and the A300 at the mid-range, the FAS 9000 and A700 at the high end, and then the addition of the A700S. All right, so that is a complete refresh of the entire controller product line. Moving on to disks and disk shelf technology, we've also completely refreshed that. So we've moved to 12 gig SAS now. So we have 2 new shelves, the DS224C and 212C. Now there's going to be a little bit of a contest here. So the naming convention, the decoder ring, so DS stands for disk shelf. The 2U, the 2 stands for 2 rack units, and then the 12 stands for, in this case of the 12, the 12 drives of the 24 drive enclosure. If you can let me know, or you can put in the chat window what the C would stand for, or how we came up with C. Brandy will send you a nice prize. We have some socks apparently. NetApp branded socks. All right.
How many pairs do you own, Tony?
I own a few.
Now, why do you own a few, Tony?
It's a long story. So, do we have anyone out there who's figured out what the C, how we got C to 12? No guesses?
Oh, Jamie says hex.
Yeah, that's right.
Jamie said, oh.
Indeed, it is hex. So yeah, so rather than putting another 2 digits for the SAS speed, we went with hex. So the engineers went with hex. So C is 12 in hexadecimal. So that's where you get our 224C and 212C. All right, so Brandy will send some nice socks out to Jamie and who else? Who's the other person?
Well, there's a couple people who responded.
All right.
They're all going to get socks.
They're all getting socks. All right, there you go. Fantastic. The technical specs on these two shelves, they are both 2 rack units. I mentioned the form factor. In the case of the DS224C, we're using the 2.5-inch small form factor drives. In the case of the 212C, it is the 3.5-inch larger form factor. Both of these systems operate at 12 gig. From a SAS perspective, they are using the 4x wide SAS channel, so each SAS channel has 40 gigs of bandwidth. You'll see on the back, unlike the existing IOM6 modules, this IOM12 has 4 ports per module rather than the 2 ports per module. In addition, we're using as part of the standard for 12 gig SAS, we are using the mini SAS HD ports. So it is a slightly different connector from the existing disk shelves. The one reason why I bring this up is that if you're an existing customer, you're looking to take advantage of these new shelves, there's a converter cable that goes from SAS to mini SAS that you'll need to make sure your engineer or your partner will make sure that you have that to take advantage of those shelves. The DS224C will support SAS and SSD drives, and then the 212C will support the NL SAS or SATA drives, and it will support some limited configuration of SSD drives for the hybrid configuration. So on the hybrid side, so if you're creating, for example, a hybrid aggregate, a flash pool with SSD drives and NL SAS drives, we will have configurations where you can buy a shelf which has a certain number of SSD drives and combined with SATA drives or NL SAS drives into it. So that's where we have that combination. From a support standpoint, from 4 to 10 terabytes on the SATA side, and then obviously supporting the full range of SAS and SSDs all the way up to the 15.3 terabyte SSDs in the 224C. For customers who have existing shelf technology, we are providing an option from an investment protection to allow you to upgrade those controller with IOM12 modules and to be supported in the new hardware platform. So if you've got a situation where you're looking at potentially upgrading your controllers to take advantage of either the new hybrid or the new all-flash FAS systems, and you've got investments in either hybrid shelves or SSD shelves, we can provide the upgrade modules to allow you to upgrade those shelves and connect into those new controller platforms. This chart here shows you the combination of shelves and what's supported. So you can see there, for example, if you've got the, an older generation 4243 at the bottom, you can upgrade it with an IOM12 module and have it supported in the 2600 or the FAS 9000 or 8200. All right. So that's the disk shelves. There's a couple of interesting things that we're doing also with, from a hardware perspective on the drives themselves. And I guess it's a combination of the drives and more so the software and how we leverage those drives. One of the things that we've done, actually sort of co-developed or kind of working with Samsung, is around multi-stream writes for SSDs. So for those of you who are maybe not so familiar with SSD technology, it is based on erase blocks, and sort of the traditional approach has been that data as it gets written, the system isn't necessarily aware of any sort of linkages between the data. So on the top side, you'll see there legacy NAND flash systems where the data blocks are all intermixed within each of the different erase blocks on the SSD media. When we need to update those blocks, what ends up happening is that we have to do an entire erase of that block. So the I/O capabilities means that we're more likely to hit that erase block because we've intermixed that data. With multi-stream write, we add metadata. So ONTAP itself has the awareness of the erase blocks, and so we can group I/O together in a more cohesive manner, meaning that the capabilities of or the way that the system will write the erase blocks or erase the erase blocks is done in a more intelligent manner. Why is that important to you? Is that by doing this, we can reduce the amount of over-provisioning. So over-provisioning is something that all manufacturers will do to SSD drives to allow us to keep a certain amount of that SSD space for doing this garbage collection activity. By writing in a more intelligent way, not only do we have some improved performance, but we can also reduce that over-provisioning. So it means that the existing 800 gig SSDs can be turned into 960 gig drives. So that's why you'll see a lot of the new systems are actually, we don't talk about 800 gigs anymore, we talk about 960 because we've been able to reduce that over-provisioning, right? Again, benefiting you, the customers, by providing you with more SSD capacity off of that same media. On the SATA side or the NLSAS side, from an industry standpoint, we're seeing drives become larger and larger. So now we have 10 terabyte SATA drives. We have some new technologies as far as cloud or archive drives, which could potentially have even lower reliability than the current SATA drives. The other things that we're running into is rebuild times. So as we talk about drives getting into 8 and 10 terabytes, I've put in there the 8 terabyte right now takes about 3.5 days to do a reconstruct. So the challenge that this creates in adopting this technology is that there's this additional risk now of a data loss event. And what RAID Tech or triple erasure coding provides, it's really an extension of RAID DP, is it provides protection against a triple disk failure. The engineers recommended for any of the drives greater than 6 terabytes, and actually for the 10 terabyte drives, we make it a mandatory capability. RAID Tech is the implementation of RAID Tech is a NetApp patented technology, and really the benefit of it is really around reducing the potential data loss event. So based on some testing that we've done, looking at 1 million drives and on the 50 year from a data loss perspective, we can see there that where RAID DP stands, as we get lower down in the graph, that's better because we're reducing the probability of a data loss event. One of the options that we've seen some vendors talk about is a triple copy. So this is where they'll take 3 copies of that data, and that's how they achieve a higher level of resiliency or protection against drive failure. When we look at where RAID Tech comes in, we can see that it's actually on par or actually a little bit better than a triple copy. The advantage, of course, comes into the usable capacity. So if I switch now to a usable capacity model, right, we can see that if we had 28 of those 10 terabyte drives and we put them in a RAID DP configuration, the maximum RAID group that we would support is 14 drives. So we would give you 2 parity drives. I know we're getting into a little bit of the math here. So we would subtract 4 parity drives. So that would leave us with 24 data drives, or 86%. If we went with the triple copy option, we would divide that 28 by 3, giving us roughly about 9 data drives, leaving us with 33%. If we look at RAID Tech, we can support up to a RAID group size of 29. So in this case, we would do a RAID group size of 28. And so we would lose 3 parity drives and leaving us with 25 data drives. So 89% efficiency from a RAID overhead perspective. So again, I know we're kind of getting into the weeds of the technology, but why is this important for you is because ultimately it means that you can safely adopt these new technologies without worrying about the risk of any potential data loss or risk to using these new technologies as they become available. To give you a quick example there, this is based on our DS 4486, so this is our high density shelf. So using those 10 terabyte drives, we can have 3.3 petabytes in a 40 rack unit, a 40 RU rack. So a tremendous amount from a consolidation standpoint. All right. Yeah, the 4 efficiencies. What was that? 3 minutes? All right, 3 minutes. I'm going to have to power through this. So some big changes on the networking side of the house as well too. So the support, we are now partnering with Brocade. So in providing Brocade Director class switches on the 32 gig side. So whether that's the work group, the mid-size, or the large enterprise, we have those capabilities, and so you can talk to your systems engineer about, if you are looking at leveraging fiber channel within your infrastructure. One of the things that we see, especially with the all-flash systems, for those workloads that absolutely need the absolute lowest potential latency, fiber channel still does provide a slight edge over Ethernet, and so we've seen also some significant improvements on a benchmark perspective, moving from 8 to 16 to 32. On the 40 gig side, we're partnering with Cisco, supporting their 9300 and 5600 switches. We ourselves are adopting the 3132Q for our cluster interconnect, and I'll quickly jump over to that slide. It is a 32-port system from a 40 gig standpoint, as well as it's got the inclusion of 4 10 gig E ports. It does support fan-out, the 40 to 10 fan-out cable, and I'll talk a little bit about that. So if we look at a a traditional, just a pure 40 gig, we'll support the passive copper cables as well as the optical cables. So that's kind of a 40 gig to 40 gig. If we're looking at 40 gig to 10 gig, we do support the passive copper cables that have the breakout of a single 40 gig on one side and then 4 10 gigs on the other. If we look at it from the perspective of a cluster interconnect, so let's say you purchase one of these new A700s, you would get part of that solution. If you were going to be using a cluster switch, you would get the 40 gig option. So you would use 2 of those 40 gig ports and you would use that 40 gig to 40 gig cable. If you then had an existing, for example, an existing FAS 6290 that was based on 10 gig for its cluster interconnect, you could use those 4 10 gig ports. And if you had, for example, an AFF 8080, you could then use that breakout cable. So you would consume one of the 40 gig ports, and that breakout cable would then be plugged into the back of the AFF 8080. The inverse, so if we look at, if you've got an existing cluster based on 10 gig infrastructure, so you're looking at, you've got that existing AFF 8080, and now you decided, hey, you know what, I really want that A700 to address my business needs. We can use that breakout cable in the inverse direction, so we would use the 4 10 gigs into the cluster interconnect switch, and then that single 40 gig port would then go back to the A700. So lots of flexibility when it comes to connectivity. Well, I think that I know I kind of rushed through that last slide. I mean, this is a quick summary slide of the hardware updates. So again, this is a complete refresh of the entire product line. Not only our hybrid systems, our flash systems, the shelves, things that we're doing on the drive media itself, the infrastructure from a 32 gig SAN, from a 40 gig Ethernet, as well as all of the innovation with the software itself to take advantage of that hardware. So with that, that brings...
I sent you the link.
Oh, that brings me to the end, but so